Good morning. So this is the third in a series of lessons dealing with systems of equations. The first lesson we looked at solving systems graphically. So whether you put it on a grid or you put it into your graphing calculator, you're actually producing two lines and you are seeing where they cross. And remember, where they cross is referred to as the solution. In the second lesson, we looked at doing the same thing, but doing it algebraically. So you don't need to graph them on a grid or use your graphing calculator. You can simply solve, and in lesson 2 it was solving by substitution, but you can solve to get that same final product, which is an ordered pair that describes where the two lines cross. Okay? The third lesson, which we're going to do today, is another way of solving a system algebraically. So in other words, without having to graph the lines. Okay? Now, why are we looking at a second way of doing it algebraically? Simply put, sometimes it's easier to solve using substitution, which we looked at in the second lesson, and sometimes it's easier to solve this way. And as you no doubt have already learned in your math experience, some people find that one way makes more sense to them, and others find that a different way makes more sense to them. And this is just another tool for you to use to hopefully get the right answer, which is kind of what we're after. Okay? So, when you solve a system using elimination, you're not isolating one variable the way we did with substitution. What you're doing is you're trying to manipulate one equation or the other so that you have the same coefficient on your x variables or the same coefficient on your y variables. And if we take a look at the first example here, you'll see that we have a coefficient of 4 on both of our y variables. Whenever you have that, or can get that through manipulating the equation, it's usually easier to use elimination. Okay? But again, you need to know how to do this for the test, but in the normal course of events, if you're doing your homework and the question doesn't specify, you use whichever method you would like. Okay? So, just as we did with substitution, we've got a nice series of steps outlining the method here. You can always pause the video when you're doing your homework and you can go over these steps. So, the first step is, if necessary, multiply each equation by a constant. Remember, we did that a lot when we were trying to simplify equations to get rid of fractions or to get rid of decimals. Multiply by a constant to obtain coefficients for x or y that are identical. Again, you know, math speak is sometimes a little cumbersome. Basically what we're trying to do is we're trying to make it so that the number attached to the two y's or the number attached to the two x's is the same number. Okay? Once you've done that, then you can add or subtract your two equations, and what that will do is that will result in the elimination of one of your variables. Yay! If you can get rid of one of your variables and you're left with an equation that only has one variable, you can isolate it and solve, which is step 3. Solve to determine the value. Step 4, substitute that solution into either of the original equations, so this is just like substitution, to determine the value of the other variable, and as always, you can check or verify your solution. If it works in both original equations, good deal, you got the right answer. Okay, so let's do the first example here. The first example here is relatively easy simply because we don't have to manipulate our equations. If you take a look at these two, you have 3x minus 4y equals 0 and 5x minus 4y equals 8. The important thing is, right here, you can see the coefficients of y are the same. Okay? So, we can skip step 1. We don't have to obtain a coefficient that's identical. It's already identical. Now what we're going to do, just like you did in elementary, we're going to subtract or add our equations. And this is where you have to ask yourself a question. I want to eliminate this term, this 4y. Will it disappear if I subtract 4y minus 4y? Or would I have to add to make it disappear? Well, if I added these two, I would get negative 4y plus negative 4y. I would actually get 8y. So I don't want to add them because I'm trying to make this thing disappear. If I subtract them, however, and go negative 4y minus negative 4y, that becomes negative 4y and positive 4y, and I will get 0. So in this case, if I add my two equations, look what happens. 3x plus 5x is 8x. Sorry. Let's back up because your teacher made a mistake. We have to subtract our two equations here in order to get it to disappear. So again, rewind, here we go. 3x minus 5x is negative 2x. Negative 4y minus negative 4y, that's like saying negative 4y plus 4y, will give me, and I'm just going to write it in here, 0y equals 0 minus 8, negative 8. Okay? A couple of things you need to be aware of. Okay? These equations are already written so that all of the like terms fall below each other. Notice how you've got the x's lined up vertically, the y's, the equal signs, which is really important, and the constant terms. They're all lined up so that one's right below the other, making subtraction or addition relatively straightforward. Okay? Let's simplify this. We don't need that 0y. We can just write it as negative 2x equals negative 8. And then look what we've got. We've got an equation now that only has one variable. And as I mentioned in the previous lesson on substitution, that's what you want to have, because then you can isolate your variable and actually get a value for x, which, remember, we're going to eventually plug into our solution, which is just an ordered pair. So let's get x all by itself. To get x all by itself, we have to divide both sides by negative 2. That will give us x equals 4, right? Negative 8 divided by negative 2 equals 4. Oops. That's just there. Now you can see it. Okay, so our x value is 4. Now let's find our y value. Take your value for x, plug it into either one of these equations. It doesn't matter which. I'm going to plug it into the first one because this first one's got a 0, and that's going to have to make things a little bit easier. Okay? So I'm going to plug my value of x equals 4 into my first equation. That will give me, instead of 3x, 3 times 4 minus 4y equals 0. Simplify. 3 times 4 is 12 minus 4y equals 0. And isolate y. Subtract 12 from both sides. Remember, always do the adding and subtracting first. 12 minus 12 is 0. 0 minus 12 is negative 12. And we're left with negative 4y equals negative 12. Last step, get rid of the negative 4 by division. Negative 4 divided by negative 4 will leave us with 1y. And again, there we go. Will leave us with 1y. Negative 12 divided by negative 4 is 3. And look, we have the answer. Okay? So We'll do a couple of more of these. I know it looks weird at first, okay? But just remember, the important thing is that step where you add or subtract, okay? Because that causes one of your terms to disappear. Let's try this one, okay? Excuse me. Now for this one, for B, you'll see that we don't have the same coefficient either in front of the y's or in front of the x's, but we can fix that, okay? Now there's a number of ways we could fix that. Some of them take more work, some of them take less work. Since we're lazy, let's go for less work, okay? Now, if we could get a 2 in front of this y, then it would be the same coefficient in both cases. Well, that's easy. If we multiply this equation through by 2, we will end up with 2y. Remember, we distribute, and that will give us a new equation, which I'll just write over here. 2 times 8x will give us 16x. 2 times minus y will give us minus 2y. Carry the equal sign. 2 times negative 10 gives us negative 20. I'm just going to rewrite this first equation so that it's still above this. So this is still 3x minus 2y equals 6. And you'll see now we have the situation we had in the first example, where we have the same coefficient of y in each case. And now, just as we did in the first example, notice that if the sign in front of the coefficient is the same, they're both minus, that's a clue that you're going to have to subtract. Okay? So you're going to have to subtract 3x minus 16x to get negative 13x. Negative 2y minus negative 2y, again, minus a negative, changes it to plus, and you end up with 0y. 6 minus negative 20 is like saying 6 plus 20, gives us 26. Again, remember the y disappears. That's what we want to happen, and we get this nice simple equation, negative 13x equals 26. We can then isolate x by dividing through by negative 13, and that gives us x equals negative 2. Well, there we go. We already have half of our solution. Okay? Next part. Take your value for x, substitute it into either equation, doesn't matter which one. I'm going to sub it into this second equation here. So, if x equals negative 2, my second equation becomes 8 times negative 2 instead of 8x minus y equals negative 10. Simplify. 8 times negative 2 is negative 16 minus y equals negative 10. Isolate y. We're going to add 16 to both sides to disappear the 16 from the left. That gives us 0. Negative y equals 6, right? Negative 10 plus 16. And then finally, remember, we don't want negative y, we want positive y. Well, that's easy. We just multiply the whole mess through by negative 1. Negative 1 times negative y is positive y. Negative 1 times 6 is negative 6. And we have our solution. Okay? We'll do one more. It's important that you get fairly comfortable with this. And why don't we do D? Because in order to do D, you're going to have to manipulate both equations, and sometimes you do. Okay, so if you look at D, you'll see that, oh, you can't see D. There we go. Now you can. if you look at D, you'll see that we can't easily multiply. First of all, we don't have the same coefficient either in front of our x's or our y's. Okay? And you can't multiply one equation to change that. In this case, what you're after is you have to multiply both equations, and you're looking for the least common multiple. Okay? So, we could try and get a least common multiple of 6 here, right? Because the least common multiple of 2 and 3 is 6. We could multiply the top equation by 3. That would give us a 6 here. And the bottom equation by 2. That would give us a 6 there. Or we could look to make the y's the same. That would involve multiplying this entire equation by 2, giving us 14y, and then the bottom equation by 7. That would give us 14y as well. Okay? Generally, try and manipulate your equations through multiplication by multiplying by a smaller number. Okay? That will give you smaller numbers in your answers, and it just makes it a little easier to do it in your head. So, what I'm going to do is I'm going to multiply the top by 3 and the bottom by 2. And what that will give me when I distribute this 3 over all my terms is 3 times 2x, 6x, 3 times 7y, 21y, and 3 times 24, 72. Okay? When I multiply the bottom by 2, that will give me 2 times 3, 6x, 2 times a negative 2, minus 4y, 2 times a negative 4, minus 8. Okay, take your time when you're doing these little steps. If you make a little mistake, you forget to change a negative to a positive or something like that, you're going to get it wrong. Okay? But, so what we've got here now is we've got two equations that are equivalent. They have the same coefficient of x, and so we can go ahead. And again, when they're both positive or both negative, you know you're going to have to subtract to make that x disappear. So 6x minus 6x will give us 0x. 21y minus negative 4, it's like saying plus 4, will give us 25y. And 72 minus negative 8 will give us, well, what's 72 plus 8? 80. Okay? This term disappears. I'm just going to check and make sure I haven't made a mistake. So 6 and 21 and 72, 6 and minus 4 and minus 8, that's right. And that's right. Okay, so we're good. Isolate y. You know this will just disappear. We can divide both sides by 25, and that will give us y equals 80 over 25, which is kind of cumbersome. Okay, you can leave these as a fraction in simplest form, so we could express that as 16 over 5, because both are divisible by 5, or you could, in this case, because it forms a terminating decimal, and only if it forms a terminating decimal, you could convert this to a decimal, and it would be 3.2. Okay? Only if it's terminating. Okay. So, we've got our x, or sorry, in this case we've got our y. It's 3.2. Now let's find our x. So again, plug the value of your y into either one of your equations, it doesn't matter which, and solve for your unknown. Okay, so I'm going to pick the second equation. So instead of 3x minus 2y equals negative 4, we're going to have 3x minus 2 times 3.2, right, our value for y, equals negative 4. Simplify. Negative 3x minus 2 times 3.2 is minus 6.4. equals negative 4. Isolate. We want to get x all alone, do the adding and subtracting stuff first, so we're going to add 6.4 to both sides, canceling it here, leaving us with negative 3x equals positive 2.4. Okay? And finally, get rid of that negative 3, divide through by negative 3, leaving us with x equals, this gives us negative 0.8, which is our x value. Negative, there we go. Negative 0.8. And there's our answer. Yes, you will sometimes get decimals, okay? That's life. How are we doing for time? Why don't we do, what else do we have here? Oh my goodness. Why don't we do G? G is a little bit different, okay? So, just let me erase this. G is a little bit different for a couple of reasons. First of all, you'll notice that in G, our bottom equation is missing the constant term, right? It doesn't have a number. And the equations are written in such a way that our terms don't fall one beneath the other. So let's deal with that first. I'm just going to rewrite this, 2x minus 29 equals 5y. Okay? And this one, I'm going to write it so that the terms line up. Okay? So I'm just going to flip this equation over, and the negative 7x will be here under the 2x. The equal sign will be here. The 3y I'm going to bring over here, negative 3y. So notice I've just flipped this equation over, and that's totally fine. Okay? You can flip it around the equal sign and everything will work out. Now, I don't have a constant term here, so I'm just going to put in a 0 just as a placeholder. Okay? It's not going to affect the equation because you know that if you add 0, that doesn't matter. And then I have two equations that line up at least. I still haven't done anything about making the coefficients the same. That's what we'll do next. Okay? So, you have a 2 and a 7 in front of your x's. So I could find the least common multiple of 2 and 7, 14, and manipulate my equations to get 14. Okay? Or I could do manipulating to get the same coefficient in front of the y. I could multiply the bottom by 5 to get 15y, and the top by 3 to get 15y. And I think that's what I'm going to do. Okay? I'm going to multiply the top by 3 and the bottom by 5. And that will give me 3 times 2x is 6x, 3 times minus 29 is minus 87, 3 times 5y, 15y. And now I'm going to manipulate the bottom. I'll multiply through by 5. That will give me 5 times negative 7, negative 35x, 5 times 0, 0, 5 times negative 3, negative 15y. So, a couple of things. First of all, now I have two equations. The terms line up nicely. The equal signs line up nicely. I have changed my equations so that I have the coefficient of y is the same number. It's 15 now. Now I can combine them. But take a look. The sign in front is not the same. We have a positive 15 and a negative 15. So this is an example where rather than subtracting, we're going to add. Okay? Because if we subtracted 15 minus negative 15, that would give us 30y. We want this thing to disappear. So if we add the equations, we'll get 6 plus negative 35, negative 29x. Negative 87 plus 0, of course, negative 87. And 15 plus negative 15 will give us 0y. So what does that do? Well, what that does is that gets rid of our y altogether, and we can isolate x. So to isolate x, we add 87 to both sides. That gives us negative 29x equals 87. Divide through by negative 29 to get rid of that. And we're left with x equals negative 3. Well, that doesn't look so bad. So we'll just put this over here. Our x value is negative 3. Take your value of x, plug it into one of your original equations. Now this one here looks particularly simple. Why don't we use it? Okay. So we say we have an x value of negative 3. That means our equation becomes 3y equals negative 7 times negative 3. I've subbed in a value of negative 3 where you see the x. Simplify the right side, negative 3y equals positive 21, right? Negative times negative. Divide through by negative 3, and that gives you y equals negative 7, which is our y value. Okay? I think maybe we'll leave it there. So we've gone over the elimination. I probably will give you another lesson next day. We're going to take a look at the practice problems in 8.3 in your assignment booklet. We'll go through those practice problems, and then I think I may post a third video where we take a look at word problems. Okay, word problems, as I said in the video on 8.2, the word problems can be kind of challenging. Okay, make sure you're doing extra practice from your textbook. Your assignment booklet has some extra practice questions there. You got to do a lot of these. You get comfortable with it, and then most students actually find that they prefer this method for solving systems. Okay? Being as it's Friday for me today, I don't know when you're going to be looking at this, I will wish you a wonderful weekend. It's sunny outside, it's June. Please make sure you take some time to go out and play.